My name is Raffaele Giaffreda. I'm the Chief IoT Scientist at FBK GreenNet, and I'm going to talk about RaptorBox, the smart IoT message brokering platform that we use in the context of the Uncap project. First of all, I'm going to position in this slide where the RaptorBox platform sits within the overall Uncap architecture. So as you can see here, the overall Uncap architecture is composed by a box, cloud, a set of components in the cloud, and a web application. So the data broker platform sits within the Uncap cloud, and it's in between the production of IoT data that happens within the Uncap box, within the user's homes or while they're on the go, and have IoT health devices monitoring their health, and the consumers of those data, which are actually reading the data through the Uncap web application. What problems we address? What problems did we need to address when we were faced with, let's say, bridging the IoT devices with the applications that the Uncap project was planning to achieve? The challenges were mainly related to the integration of IoT devices within the Uncap intended services. For that, we had, of course, to tackle complexity of integration coming from the fact that we have a heterogeneous set of IoT devices, and we had to integrate that into an existing infrastructure. So we needed to deal with and interact with different IoT devices, speaking different languages, needed to identify them, and speaking on different protocols. Of course, that had to be done in a secure way, given the sensitive nature of data being transported. We wanted also to provide device and data access control. And one of the requirements was, of course, to create something which would scale up, bearing in mind that the number of patients and users of the Uncap platform would be considerable, and they would all be uploading their data either through streaming applications or every so often. So the other problem that we wanted to solve was making available a platform which would enable quick cycles of validation as the code and the solution were being designed and deployed. So, in a nutshell, we had to take care about device integration and management in an easy way. Made securely, made in a scalable way, and made it such that the developers would have access to configuration interfaces for those devices that were planned to be used within the overall Uncap solution. So in this particular context, we proposed the use of this smart IoT data brokering platform called RaptorBox, which is illustrated here in the picture. So as it can be seen on the left-hand side of that box, there is the number of IoT wearable devices that can produce data. And then the platform is composed by two main blocks. One is the message broker itself, and another one is a data workflow management component, which can be used in order to manipulate the data that are handled by the message broker. Of course, there is an opportunity to give access control and authorization to seeing the data that are managed by the broker and to secure the communication. All those services are exposed through RESTful APIs, which have been used by the partners of the project in order to, let's say, publish data to the RaptorBox platform and extract and subscribe to data from this. In details, what RaptorBox provides is a means for device virtualization according to a common device modeling, which marries the Web of Things paradigm. Then it has an IoT data brokering component, as we've seen, that is providing scalability by design and protocol support for many different protocols that can be used nowadays in order to extract data from IoT devices. It also has opportunities for data caching and real-time event processing and querying. I was mentioning the data workflow management, which enables also the rapid IoT application prototyping. But the key feature that we wanted to exploit from this solution was the flexible access control and authorization for devices and users, as well as the secure communication and interaction with devices that the platform enables. Of course, this is something that was easily integrated through the APIs that the platform exposes to the external developers. In terms of benefits, the platform enabled us to save cost and time while integrating IoT devices in the Uncap solution. It is a platform that scales up because it's been deployed also on a commercial cloud platform. And it can certainly hide complexity by exposing those APIs that are easy to work with from a developer's perspective. Of course, it has the benefits of reliability and extensibility, as well as control coming from widely adopted open source components. So the platform is built on Apache Artemis, Elasticsearch, and Couchbase database. So how does it work in the context of Uncap? So RaptorBox, in this case, we will see in this slide how we can publish information via RaptorBox. The picture here in the slide illustrates the Uncap box where the data is generated and the box representing the data broker. So when we want to publish information from a user's wearable or from the environment in which a user is, the first thing that the user has to do is to log in, putting the user ID and password for the Uncap application on the smart device that he has got. That message, that login is handled by the user management module, which then will create at this point also a single sign-on token for using the RaptorBox service. That will be associated with the user ID, which we have just made the login with. And the token is returned to the application running on the Uncap box, which is meant to publish the data measured from the user. This is step number 3. At this point, we are all set to make sure that the data sources can indeed publish data to the IoT data broker RaptorBox. As it can be seen, a packet containing an update or a packet containing a measurement is made of the user ID, the token that has been generated for that particular user, as well as the data itself. Once the data broker receives that request for publish that data, the next step is takes place, step number 5, where the token is extracted and checked with the user management to make sure that that particular user is allowed to publish on the IoT data broker platform. If the single sign-on token is still allowed, then the user management module sends an OK, this is message number 7. At that point, the data broker can extract the payload from the message and deliver that data through the PubSub channels. And this is basically using an MQTT platform, that message can be delivered to all the subscribers, starting from the user itself, that can see the data as it's being measured, as well as any other subscribers that have interest in seeing that data, such as the doctor, family members, and so on. On the extraction side, we want to make sure that only allowed users can subscribe to the channels to which the IoT data broker publishes the data being measured. So in this particular slide, we are showing how that gets done within the context of a web app session. So the picture at the bottom shows the web app being accessed, for example, by a doctor, and it shows also the user management module, which plays a role in this, as well as the IoT data broker. So let's assume that a doctor wants to visualize some data from a particular patient. So the first thing he does, let's say for the example's sake, the name of the doctor is Dr. Kevin. Dr. Kevin has to authenticate itself on the data broker platform, and it issues a message that is routed from the data broker to the user management, and the user management provides back to the data broker a message saying, okay, Dr. Kevin is allowed to use the data broker platform, and it also provides what the policy for Dr. Kevin is. This is access policies for Dr. Kevin. That information is stored on the IoT data broker cache in order to handle any further requests that come from the web app during that session from Dr. Kevin as web app. So this is a picture here with message number 5, where the Dr. Kevin asks from the web app application to see the data of patient 2. So that incurs a patient 2 subscribe message being sent to the data broker. After that, the data broker checks that Dr. Kevin is indeed allowed to visualize the data of patient 2 by looking at the policy, and indeed, as a result, the current the relationship to the channels, to the subscribe channels is made, and the patient data gets visualized on Dr. Kevin web app. Now, in terms of further information, and I would conclude with this slide, this is a summary of how that can be done in terms of using the IoT data broker to publish data from a new IoT device. That can be done either via the Uncap box, so, and that is using the master app of the Uncap box, or it can be done via directly uploading data directly from the new IoT device to the data broker through a different procedure. The documentation and code is available at that link, and for any further information related to this, please feel free to contact me at the email address in the last line of this slide.